Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The substrate is a tosylate, OTS, heated, delta, indicating a pyrolytic elimination, E1 or E2. Tosylates are good leaving groups, and heating favors elimination. This is an E1 or E1Cb elimination proceeding through a carbocation intermediate or a concerted pyrolytic pathway. Moving on to the next step. The molecule is PHC, CH3, to C14H, OTS, CH3. C14 bears OTS and H, flanked by the quaternary carbon, bearing pH, CH3, CH3, and a terminal CH3. Moving on to the next step. If OTS leaves from C14, a secondary carbocation forms at C14. However, adjacent to C14 is a tertiary carbon bearing pH, CH3, CH3. A 1,2-hydride or 1,2-methyl shift could occur, but more importantly, the phenyl group can migrate 1,2-phenyl shift from the adjacent tertiary carbon to C14 to give a more stable tertiary, benzylic, carbocation. Alternatively, a 1,2-methyl shift from the adjacent carbon to C14 can occur. And for the final step, if a methyl group migrates from C, pH, CH3 to C14, which lost OTS, the carbocation moves to the carbon that originally bore pH and 2 methyls. After methyl migration, the carbocation is at the original C, pH, CH3 position, now tertiary, benzylic. Then elimination of a proton from C14 gives the alkene. After 1,2-methyl shift, carbocation at C bearing pH and 1 CH3, the other CH3 migrated to C14. C14 now bears H, CH3, migrated, CH3, original, and is adjacent to the carbocation. Loss of H from the C14 position gives CH3 to C is equal to C14, pH, CH3. This means the double bond is between the unlabeled carbon, bearing 2 methyls, and C14, bearing pH and CH3. This matches option C, CH3, to C is equal to C14, pH, CH3. Option C gives a trisubstituted alkene, 2 methyls plus pH methyl is equal to tetrasubstituted effectively, which is highly stable. The rearranged carbocation followed by elimination gives the most stable, most substituted alkene. A has C14 bearing 2 methyls on the double bond carbon. This would require C14 to gain an extra methyl, inconsistent with the shift. B gives a terminal vinyl group at C14, less substituted, not the major product. D has 14CH3 as a substituent on the double bond, implying the label moved to a methyl group. This would require a different type of rearrangement and gives a less substituted product. Therefore, the correct answer is C. Therefore, the correct answer is option C.